December 1971. The United States Congress votes to kill a tank program that has consumed close to a decade and hundreds of millions of dollars. Not one unit will ever reach a battlefield. Not one will ever be issued to a soldier. The program dies in a budget line, buried inside a defense appropriations bill, with $20 million set aside just to shut it down cleanly. 8 years earlier, two nations had promised each other something no one had built before: a single tank, engineered jointly by the United States and West Germany, that would out-armor, outgun, and outthink anything the Soviet Union could put across the Fulda Gap. It was supposed to standardize NATO's armored fist. It was supposed to replace two aging tank fleets with one machine, built once, bought twice. What it produced instead was a rotating driver's seat that turned with the turret, a gun that could fire a guided missile through its own barrel, a suspension system that could kneel a 60-ton vehicle like a camel, and a final unit cost that had climbed to nearly $1 million, 5 times what anyone had promised Congress it would cost. 2 governments, 1 tank, 0 units built. The technology did not disappear when the program did. It resurfaced, piece by piece, inside a tank that would go on to win wars the MBT-70 was never allowed to fight. In 1963, the armored doctrine of the NATO alliance rested on a single unspoken assumption: that numbers would decide the next European war, and NATO did not have them. Across the inner German border, Warsaw Pact planners could commit thousands of tanks to a single axis of advance. American and West German planners, doing the arithmetic on paper maps in Bonn and Washington, understood they could not match that number tank for tank. Their answer was not more tanks. It was a better one. A single design so advanced that quality could substitute for quantity. The tanks in NATO service in 1963 were, by the standard of what was coming, already obsolete in concept if not in age. The American M60, Patton, and the West German Leopard 1 were sound designs, built around a conventional formula: rolled steel armor, a mechanically stabilized main gun, a torsion bar suspension that gave a hard, jarring ride across open ground. A loader knelt in the turret basket, hands moving by muscle memory, feeding rounds into the breech by hand. A job that took strength, training, and time the tank might not have in a fast-moving engagement. It was a formula that had not fundamentally changed since the end of the Second World War. Both governments believed this formula had reached its ceiling. Steel could only be made so thick before the engine could no longer move it. A human loader could only work so fast before a well-drilled Soviet crew, firing in disciplined 3-round bursts, put 3 shells on target first. The tank as an idea had not failed, but it had stopped evolving, and everyone building one in 1963 could feel the difference between refining an old machine and needing an entirely new one. Neither Washington nor Bonn believed they could afford to solve this problem twice. A joint program made sense on paper for reasons that had nothing to do with tank design and everything to do with politics and cost sharing. Standardized ammunition across the alliance, a single production line splitting research costs between 2 treasuries, 1 tank fighting under 2 flags. It was, on paper, the most rational decision either government's defense establishment had made in a decade. It was also the decision that would take 8 years and hundreds of millions of dollars to prove wrong. The joint program was not the product of tank designers meeting in a workshop and finding common cause. It was the product of a memorandum, signed by 2 governments in 1963, that put policy ahead of engineering and expected engineering to catch up. On the American side, the push came from the top of the Pentagon itself. Robert McNamara, Secretary of Defense, had built his reputation at Ford Motor Company before entering government, a numbers man, trained to see a production line as a system to be optimized, not a craft to be practiced. He looked at NATO's armor picture the way he had once looked at an assembly line. 2 allied nations building 2 separate tanks to fight the same war was not tradition, it was waste. A single design, split in development cost, doubled in production volume, was the kind of efficiency McNamara's entire career had been built on proving. On the West German side, the motivation ran deeper than economics. Less than 2 decades removed from total defeat and the dismantling of its arms industry, West Germany's defense establishment saw the joint program as something closer to vindication, a return to the table not as a defeated power but as an equal partner. its engineers standing shoulder to shoulder with America's, its Bundeswehr fielding a tank built with its own hands and its own patents. For Bonn, the MBT-70 was never only about armor thickness. It was about proving West Germany belonged in the room where NATO's future was designed. Both governments signed the agreement without resolving the harder question underneath it: whose standards would govern the design? The United States built to imperial measurements, inches and pounds. West Germany built to metric, millimeters and kilograms. The U.S. Army wanted a gun system compatible with a guided missile program already years into development at home. The Bundeswehr wanted a diesel engine from a domestic manufacturer. It already trusted, built to specifications its own logistics chain could support without American parts. Neither side raised these differences as deal breakers in 1963. Both treated them as details to be resolved once real engineers sat down at a real drafting table. That optimism did not survive first contact with the drafting table. But in 1963, standing beside each other at the signing, American and West German officials had every reason to believe they were opening the most important tank program either country would ever build. One machine, one production standard, one answer to the Warsaw Pact, built by two nations who had fought each other twice in one lifetime and were now, for the first time, going to build a weapon of war together instead of against each other. The marriage was signed. The disagreements had only been postponed. By 1965, the drafting tables in Detroit and Ohio, twinned with counterparts in Germany, had produced a design that did not resemble any tank in NATO service. It looked, to the engineers who built it, less like an evolution of the M60 and more like a machine assembled from a wish list of everything a tank had never been able to do at once. The main gun was the clearest sign of that ambition. The XM150, a 152mm gun/launcher, a single barrel engineered to fire both a conventional shell and a guided missile through the same tube, was designed to let one weapon do the job of two. Fired conventionally, it functioned as a standard main gun. Loaded differently, it could launch the Shillelagh, a missile guided to its target by an operator tracking it through the sight, capable of striking armor at ranges a standard gun's flat trajectory could never reach with the same accuracy. No production tank anywhere in the world combined both capabilities in one weapon. West German engineers, skeptical of the missile's reliability and cost, pushed instead for a conventional 120mm smooth gun, a disagreement that would resurface later and matter more than either side yet realized. The suspension told a similar story. A hydropneumatic system, hydraulic fluid and compressed gas working together in place of steel springs, let the crew raise or lower the entire hull, tilting the vehicle to change the gun's elevation or lower its silhouette behind cover. Engineers called it kneeling. A 60-ton machine that could crouch like an animal bracing to strike was not a capability any Soviet tank crew had ever had to plan against. Inside the hull, the crew arrangement broke a design assumption that had held since the Second World War. The driver no longer sat in a fixed position in the hull front. He sat in a rotating cupola mounted in the turret itself, his seat and instruments turning with the gun, meaning that whichever direction the turret faced in battle, the driver's view faced the same way, and the fourth crewman, the loader, was gone entirely. An automatic loading system fed rounds into the breech mechanically, reducing the crew from 4 men to 3 and removing the single job most likely to slow a tank down under fire. Above the turret sat a remotely operated 20mm auto cannon, a machine gun-sized weapon a crewman could aim and fire from inside the armored hull without exposing himself to defend the tank against low-flying aircraft or infantry at close range. The fire control system paired a laser rangefinder, which measured distance to a target in a fraction of a second, with an early ballistic computer that adjusted the gun's aim for range, angle, and the tank's own movement, a level of first-shot accuracy no crew in NATO had trained with before. A night vision system let the crew fight in darkness that had once belonged entirely to whichever side moved first at dawn. On paper, in engineering reviews on both sides of the Atlantic, the MBT-70 was not an improvement on the tanks it was meant to replace. It was a different category of machine entirely, and every one of these systems, individually promising, was about to prove far harder to build, integrate, and pay for than anyone in 1963 had allowed themselves to imagine. The disagreements postponed at the signing table in 1963 did not stay postponed once engineers on both sides had to make the design real. They surfaced one by one, and each one cost time, money, or both. The measurement systems collided first and most mundanely. American drawings specified inches, pounds, and imperial threads. German drawings specified millimeters, kilograms, and metric threads. Every component that crossed the Atlantic between the two design teams, a bolt, a bracket, a fitting, had to be converted, cross-checked, and sometimes remachined to match a standard the other country's factories could actually produce. It was not a dramatic failure. It was 1,000 small frictions, each one adding weeks to a schedule that had none to spare. The engine was the second fracture, and a more serious one. The United States wanted a Continental-built diesel, drawing on an American manufacturer its army already trusted for logistics and parts supply. West Germany wanted an MTU-built diesel, from a company with deep roots in German industrial engineering and a domestic supply chain the Bundeswehr did not want to depend on Washington for. Neither government would fully concede its own engine to the other's manufacturer, and for a program built on the promise of one standardized tank, running two different engine programs in parallel was its own kind of quiet admission that the marriage was not entirely equal. The gun was the deepest fracture. American planners had already invested years and real money into the Shillelagh's guided missile program and wanted the 152mm gun/launcher built around it, a single weapon system that could outrange any conventional tank gun in the world. West German engineers were unconvinced. The missile's guidance system was new, its reliability under battlefield conditions unproven, and its cost per round dramatically higher than a conventional shell. Bond's engineers argued, with real technical justification, for a proven 120mm smoothbore gun instead, accurate, reliable, and already advancing in German industry independent of the joint program. Neither side was wrong on the merits. That was what made the disagreement so hard to resolve. This was not a case of one country's engineers being right and the others being stubborn. It was two defense establishments, each with a legitimate technical case, unable to agree on which risk was worth taking. Even the human body became a design dispute. American soldiers, on average, ran taller than their West German counterparts, and the low-profile hull that made the MBT-70 harder to hit also made it a tighter fit for a 6-foot American crewman than for the German Army's average recruit. A tank designed to fit one nation's soldiers comfortably fit the others less so, a detail that sounds minor beside a 152mm gun, but one that any tank crew in any army will tell you is never minor at all. None of these disagreements on their own threatened to end the program. Each one, individually, looked survivable. A compromise to be found, a committee to convene, a specification to split the difference on. But committees take time, and time, on a program already running behind its own optimistic 1963 schedule, was the one resource the MBT-70 could least afford to spend. Every disagreement in the design process eventually became a number, and every number eventually became a problem for someone standing in front of a congressional committee. When the joint program was signed in 1963, the projected cost per tank had been modest enough to make the entire pitch to Congress and the Bundestag sound like fiscal common sense. One advanced design, shared development costs, cheaper per unit than either country building its own tank alone. By the time prototypes were rolling off the line in the late 1960s, that projection had collapsed. The unit cost had climbed to nearly $1 million per tank, roughly 5 times the original estimate given to the governments funding it. This was not a modest overrun that a budget amendment could quietly absorb. It was a 5-fold failure of the very premise the program had been sold on. The reasons were not a single mistake, but the accumulated weight of every technical ambition in Chapter 3. A rotating driver's cupola, a hydropneumatic suspension, an automatic loader, a laser rangefinder paired to a ballistic computer, a dual-purpose 152mm gun/launcher, a remotely operated autocannon. Each system had been engineered, tested, and integrated largely from scratch, and each one had its own budget line that had grown past its original estimate. There was no single villain in the cost overrun. There were a dozen ambitious subsystems, each individually justified, collectively unaffordable. Reliability problems compounded the cost problem rather than following behind it. Systems this new failed in testing more often than proven, conventional components did, and every failure meant redesign, retesting, and delay on a defense program is never free. Time was not a hidden cost of the MBT-70. It was one of the largest costs on the ledger, and it kept growing for exactly as long as the engineering kept proving harder than promised. By 1969, the pattern was undeniable to officials on both sides of the Atlantic. The tank that had been sold as a cost-saving measure through shared development was now, individually, one of the most expensive armored vehicles ever proposed by either government, and neither government's legislature had signed up to fund a machine that expensive. In Bonn, that arithmetic was becoming impossible to defend to a Bundestag that had trusted the original projections. In Washington, it was becoming impossible to defend to a Congress already straining under the cost of a war in Vietnam that showed no sign of ending cheaply. The MBT-70 had not failed to work. Prototypes ran, systems functioned, engineers on both sides could point to genuine technical achievement. What it had failed to do was cost anything close to what either government had been promised. And in a defense program built entirely on the argument that shared cost made an advanced tank affordable, a five-fold overrun did not just strain the budget, it erased the program's entire reason for existing. In 1969, West Germany made the decision the numbers in Chapter 5 had been building toward for years. It withdrew from the MBT-70 program entirely. It was not a decision made in anger, and it was not framed, publicly, as an accusation against the United States. It was framed as arithmetic, the same arithmetic that had been eroding the program's justification since the late 1960s. The unit cost had climbed to 5 times the original estimate. The technical disputes over the gun, the engine, and the design standard had never fully resolved. They had only been managed, meeting by meeting, for 6 years. And West Germany, unlike the United States, had an alternative already taking shape on its own drafting tables. A path to a new tank that did not require agreement with a foreign government on every specification, every supplier, and every design compromise. That alternative would become the Leopard 2. West German engineers, freed from the compromises the joint program had demanded, could build to their own standard. A conventional, combat-proven 120mm smoothbore gun instead of a dual-purpose missile launcher still years from reliable service. A suspension and armor package refined without a partner nation's competing requirements. A design philosophy built around what German industry could manufacture reliably, at a cost the Bundestag could actually approve. The withdrawal was not West Germany abandoning the pursuit of an advanced tank. It was West Germany concluding that the fastest path to one no longer ran through Washington. For the United States, the withdrawal changed everything about the program's math without changing its ambitions. The entire cost-sharing premise, one design, two treasuries, doubled production volume, was gone. The United States could continue alone, but alone meant funding a design built for two nations' requirements, at a cost per unit already 5 times over budget, with none of the burden sharing that had made the number politically survivable in 1963. The program that had been sold to Congress as an efficiency was now mathematically the opposite. A single nation carrying the full cost of a design compromised by years of accommodating a partner that was no longer in the room. Washington did not cancel the program in 1969. It chose instead to keep going, scaling the design down, stripping out cost, and hoping a leaner version could survive scrutiny that the original could not. That leaner version would carry a new name. It would not carry a new outcome. With West Germany gone, the United States did not abandon the program. It tried to save it by making it smaller. The new effort took shape through 1969 as the Army and the Office of the Secretary of Defense worked to convert the existing MBT-70 design into what internal reviews called an austere alternative. A version built entirely from American-made components, stripped of the joint development compromises, and re-engineered to cut cost wherever cost could be cut. In December 1969, the redesigned program was reviewed at the highest levels of the Defense Department. The following month, the recommended changes were approved. The design modifications were projected to reduce the tank's estimated unit cost by nearly 30%, a real improvement, but nowhere near enough to undo a 5-fold overrun with a 30% cut. The new vehicle kept the joint program's silhouette and much of its engineering DNA, but the ambition inside it had been quietly reduced. The dual-purpose 152mm gun/launcher remained, but other systems that had driven cost and complexity were simplified or removed. For over a year, the Army used a composite designation, MBT-70 XM803, as if unwilling to fully let go of the original program's identity even while building its replacement. In February 1971, that composite name was dropped. The tank had a new designation of its own, XM803. It did not solve the problem it was built to solve. Critics inside and outside the Pentagon pointed out what the redesign had actually produced: a vehicle that cost nearly as much as the original MBT-70, while delivering capability closer to the aging M60 it was supposed to replace. The program had cut cost by cutting ambition, and in doing so, it had cut away the very justification, a categorical leap in tank capability, that had made the original price tag defensible to anyone in the first place. Congress noticed. In September 1971, Senator Thomas Eagleton introduced an amendment to strip $35.3 million in funding earmarked for XM803 prototype production. The amendment was defeated on the floor, a narrow reprieve and the last one the program would get. The defeat bought XM803 3 more months. It did not buy it a future. The tank that had once promised to leapfrog Soviet armor with a rotating cupola, a kneeling suspension, and a missile-firing main gun was now fighting for its life over a $35 million line item, a fraction of what the joint program had already spent proving it could not deliver what it promised. The rescue had not restored the MBT-70's original ambition. It had only postponed the reckoning by roughly 90 days. The Eagleton Amendment had failed in September. It did not matter. 3 months later, Congress finished what that vote had almost done. In December 1971, the Defense Appropriations Bill reached its final form, and inside it was the language that ended nearly a decade of joint engineering ambition. Congress canceled the tank, not the missile system inside it, not one contractor's contribution. The program itself, in its entirety, was struck from the federal budget. The bill was not vindictive. It was administrative. It appropriated $20 million to cover the cost of shutting the program down cleanly. Severance for a design that had never fired a shot in anger, never been issued to a single soldier, never left the proving grounds it had been tested on since the late 1960s. It appropriated another $20 million for something else entirely, the beginning of a new tank program, built from scratch, unburdened by a foreign partner's specifications or a decade of accumulated compromise. The number told its own story. $20 million to bury the MBT-70. $20 million to start over. Two identical figures, one marking an ending and one marking a beginning, sitting side by side in the same bill. The Army did not wait. The following month, January 1972, it opened a new design study. The Army called it the XM1. Within a decade, that program would become the M1 Abrams, the tank that would define American armor for the next half-century. No press conference marked the MBT-70's cancellation. No ceremony retired the prototypes. The vehicles that had been built, a handful of pilot units, tested at Aberdeen Proving Ground, admired by the engineers who built them and never seen by the soldiers who might have crewed them, were simply set aside. One of the 2 authorized pilot vehicles had never even been completed. 8 years, 2 governments, hundreds of millions of dollars, funneled through 2 national treasuries, converted between 2 measurement systems, argued over in 2 languages, and reduced, in the final accounting, to a single line in a budget bill and a check written to close the books. The tank was dead. The technology inside it was not. The money that built the MBT-70 was gone the moment Congress canceled it. The engineering was not. It moved in January 1972 directly into the program that would replace it. And the story of what actually transferred is more precise and more interesting than the version repeated on most defense channels. The claim that circulates most widely is the simplest one, that the M1 Abrams is, in effect, the MBT-70 finished under a different name. That claim overstates it. The Abrams program started with a new design philosophy from the ground up, a conventional turret layout, a human loader restored to the crew, a hull built around a different armor concept entirely. The rotating driver's cupola did not survive into the XM1. Neither did the automatic loader. What transferred was not the MBT-70's shape. It was the MBT-70's proof of concept, the demonstrated feasibility of systems that, in 1963, had existed only on paper. The fire control system is the clearest example. The pairing of a laser rangefinder with a ballistic computer, first proven under fire, under budget scrutiny, and under 6 years of testing on the MBT-70 program, carried directly into the Abrams and its successors, giving American tank crews a first-shot accuracy advantage that would prove decisive in combat decades later, in a desert war few in 1963 could have predicted. The hydropneumatic suspension research, while not adopted wholesale, informed suspension and mobility engineering across the next generation of American armor. Even the composite armor concepts explored under the MBT-70 program fed directly into the classified armor packages later fitted to the Abrams, technology whose exact composition remains protected to this day, but whose developmental lineage traces back through a canceled program few Americans have ever heard of. The gun told a different, more ironic story. The United States had built its entire case for the 152mm gun/launcher on the promise of the Shalele missile, the very feature West German engineers had resisted from the start, preferring a conventional 120mm smoothbore. When the M1 Abrams reached its A1 variant in the 1980s, it was armed with a 120mm smooth gun, a license-built variant of a German gun, developed independently after West Germany walked away in 1969. The nation that had pushed hardest for the missile-capable gun ended up arming its flagship tank with the conventional weapon the other side had argued for all along. West Germany's path ran in parallel. Freed from the joint program's compromises, German engineers built the Leopard 2 around exactly the principles they had fought for and lost inside the MBT-70 partnership: a proven gun, a simplified crew arrangement, a design optimized for what German industry could reliably manufacture rather than what a shared specification demanded. The Leopard 2 entered service in 1979. The M1 Abrams entered service in 1980. Two tanks, born from the wreckage of one failed marriage, arriving within a year of each other. Each one, in its own way, a vindication of the argument its country had lost at the negotiating table a decade earlier. Neither the Abrams nor the Leopard 2 is the MBT-70. Both are what happened after two nations stopped trying to agree with each other and built separately exactly what their own engineers had wanted to build all along. No joint main battle tank program between two NATO nations has been attempted since. The MBT-70 remains, more than half a century later, the alliance's one real experiment in building a single tank for two flags, and the result of that experiment was not a tank at all. It was a lesson expensive enough that no defense ministry on either side of the Atlantic has volunteered to relearn it. The verdict on the program depends entirely on what question is being asked. As a procurement effort judged by its own stated goal, one standardized design, shared cost, doubled production, the MBT-70 was an unambiguous failure. 8 years and hundreds of millions of dollars produced a handful of prototypes, one of them never even completed, and 0 units in service with either army. Measured against the promise made in 1963, there is no version of the story where the program succeeded. As an engineering effort, the verdict inverts almost completely. Nearly every system that made the MBT-70 radical on paper, the laser rangefinder paired to a ballistic computer, the hydropneumatic suspension research, the composite armor concepts, even the dual-purpose gun concept that proved impractical but proved the missile-through-a-barrel idea was possible, resurfaced, refined, and separated from the compromises that had strangled it, inside two of the finest tanks the post-war world has produced. The M1 Abrams and the Leopard 2 are today considered, by most serious military assessments, among the two best main battle tanks on Earth. Neither would exist in its current form without the failure that preceded it. That is the argument the MBT-70 program actually settled, even though nobody signing the 1963 agreement intended to settle it this way. A single design, built to satisfy two nations' compromises at once, could not survive contact with the actual difficulty of building an advanced tank. Two designs, built separately by engineers, finally free to build what they believed in, could, and did, within a year of each other, arriving at excellence from opposite directions. The MBT-70 never fired a shot in anger, It never carried a single soldier into a fight it was built for. Congress spent $20 million just to close its file. Two nations tried to build one tank and built nothing. They walked away and built two of the best tanks the world has ever seen.